Good day to you. I'm Gallo Trisha Jheziel Azur, and this will be my video submission for the Emath 1 assignment.
This is the formula I used for this column, and the dollar signs here are absolute references used to lock the values b and c, which basically means that with the dollar signs, b and c are constant values for this whole column to refer to when following the equation y equals x squared plus bx plus c. Without these dollar signs, the values for b and c will be relative references. And that basically means that the b and c values are constantly changing to the next row of their respective columns, which would all just be the default 0 as no numbers are inputted. So with these dollar signs, I would be able to get an accurate answer / output in this column when inputting the values b and c. Moving on, here the numerical discriminant is obtained by using the equation b squared minus 4ac. And the two x values here are found by using the quadratic formula to find both x values. The a value being used in this quadratic equation XL formula is 1, as it is the coefficient of x squared in this equation. Now you should be thinking, how does the b and c input shift the graph based on the completed square form? Well, I'll gladly answer that. This y equals x squared equation can be rewritten as f of x equals x squared. So to better understand the completed square form from f of x equals x squared, I'll first have to input x plus b over 2 into the function instead of x. Then I would add c minus b squared over 4 to both sides of the equation, which would then give me this equation. So from what we know about functions and graphs, since b over 2 is inside the function and is either being added to or subtracted from x, the graph shifts by b over 2 units to the left if b over 2 is positive, or shifts to the right by b over 2 units if b over 2 is negative, all while staying parallel to the x-axis. And focusing outside of the function, c minus b squared over 4 works similarly to b over 2. However, it shifts the graph by c minus b squared over 4 units, either upwards when c minus b squared over 4 is positive, or downwards when c minus b squared over 4 is negative, all while staying parallel to the y-axis. Therefore, my conclusion for question 4 will be, based on the completed square form, b over 2 in bracket x plus b over 2 bracket square shifts the graph to the left if it is positive, and shifts the graph to the right if it is negative. C minus b squared over 4 shifts the graph up if it is positive, and shifts the graph down if it is negative. Now onwards to the next question, how does different discriminant values change the solutions? To answer that, the discriminant determines the nature of the roots in a quadratic equation. So, when the discriminant is more than 0, there will be two real solutions. This is because when you draw out the graph of a quadratic equation with a discriminant higher than 0, there would be two x-intercepts in the graph. When the discriminant equals to 0, there will only be one real solution. This is because the graph for this will only have one x-intercept. Now lastly, when the discriminant is less than 0, there will be two imaginary solutions, as the graph for a discriminant less than 0 will have no x-intercepts. And to find these imaginary solutions for when the discriminant is less than or equals to 0, you'd have to find x in terms of j, where j equals square root -1. Hence, my conclusion for question 5 is that when the discriminant is more than 0, there will be two real solutions. When the discriminant equals 0, there will be one real and one imaginary solution. And when the discriminant is less than 0, there will be two imaginary solutions.
And with that, thank you for watching this video.